how do we express a probability? I've told you that we can think of probability as a proportion. So it's always expressed as a number between 0 and 1. Okay, so this could be a decimal or a fraction or a percentage. Those are all fine, but it's going to be between 0 and 1. You can't have a negative probability and you can't have a probability over 1. So never greater than 1. So let me give you an example. So for a standard die, each number will come up on average over the long term 1/6 of the time. So these are all equally likely to roll each of these numbers, and so any one of those numbers, every roll, it's 1 in 6 probability of getting that. So 1 in 6, that's the same as 0.16 or 16% probability. Those are all the same. So we could write that if we call the probability of rolling, so let's say the probability A of rolling 6. So then we say P of A is 1/6 or 0.16 or 16%. Those are all fine. Now there are some cases which are slightly special cases, so probability of an impossible event. So the probability of rolling a 7 with a single 6-sided dice, that's 0, and the probability of an inevitable event is 1. So inevitable event, for example, rolling a number between 1 and 6. Okay, so let's highlight that. It's always expressed a number between 0 and 1. Okay, so now I've got another idea to talk about, which is converse probability. So that means probability of not A. So for example, in our example here, if we're talking about rolling a 6, then not A would be rolling a 1, a 2, a 3, a 4, or a 5. And we draw that with on these squiggles. So the probability of not A is always 1 minus the probability of A, because probabilities are always a proportion out of 1. So for, as I said, for this example, so the probability of not A, sorry, I wrote this wrong, so that's minus the probability of A. So if we've got an exhaustive sample set, then we can work it out. So for the probability of not A, so that's 1 minus 1/6, which is 5/6, which makes sense because that's all these guys, 1, 2, 3, 4, 5, and just missing out the 6. So that makes sense. There's this idea of converse probability that we write using this squiggle.